So this is a projectile motion problem, and it gives you the formula. This is straight from the book, but it says the height in feet h, so h represents height, of an object shot upwards into the air with initial velocity, and this is pronounced v naught. You can say v sub 0, but they usually say v naught. That's the initial speed that you're throwing the object upward. And t after t seconds. So t represents time in seconds, and it's given by this formula right here. So that formula is something we're going to need. It's a formula for projectile motion. So you have, you're standing in your backyard and you're going to throw a baseball in the air. So you throw the baseball up. When you throw it up, it has a starting velocity or an initial velocity of so many, feet per second. But after time, the ball's going to slow down, and then eventually it's going to start coming back down. It's going to hit you or the ground, or maybe you catch it. If it's me, I probably wouldn't catch it. But how high off the ground that ball is, that is the height. So let me draw a little person here. This might explain it better. So here we are. We're going to here's our mitt. We're going to throw the ball up, and the ball goes up, and it gets to a certain height, and then it's going to start coming back down, okay? So that's because of gravity. Anyway, how high off the ground the ball is, that is the h. All right, and t represents time, how long it's taking. Okay, so it says an arrow is shot from the ground into the air at we're going to need that formula, at an initial speed of 108 feet per second. So that's the speed, that's the initial speed, that's the v naught. Okay, use the formula to determine when the arrow will be 180 feet from the ground, round to the nearest tenth. Okay, so the h, the height, is equal to negative 16t squared plus, and now our v naught is 108 t. But we also know the height. We're trying to figure out when it's going to be 180 feet from the ground. So we want to know 180 equals negative 16t squared plus 108t. And they actually use these things, to, if you're launching missiles or rockets or something like that, we use these formulas in the Earth's atmosphere to predict how high something is going to be off the ground. Okay? Alrighty. Now, I wanted to say, it says an arrow, right? So here you are, and you're shooting an arrow. And the arrow's going to go up in the air, and then eventually that arrow's going to come back down and probably hit the ground or a target or something like that. So possibly there could be two times when it's 180 feet off the ground. Once on the way up and the other on the way down. But we'll see what happens in this problem. Okay, so I'm going to subtract, it's a quadratic equation, so I'm going to subtract the 180. And I'm going to hope that 16 goes into 108. So let's see if it does. 108 divided by 16. Nope, it didn't. Okay. Well, it didn't go in evenly. So I could divide things by 4. I think 4 will go into everything. So let's do that. Let's divide. I don't want to divide. In fact, let's divide by a negative 4. We're allowed. It's not 0. I'm going to divide everything by negative 4. And then I think this is going to make my quadratic equation a little bit nicer to work with. All right, so then I still have my 0. Then I have 4t squared minus, let's see, how many times? 27t plus 180 divided by 4. 45. Okay, now, do I want to try to factor it? I don't really want to try to factor it. Do I want to complete the square? No, not really. I want to just go to the formula. So, it might not be the easiest way to do it. Maybe it factors, but I'm not going to figure that out. So, the formula, the quadratic formula, t is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So now I have to know what my a, b, and c are, right? So a is 4, b is negative 27. So it's going to be the opposite of negative 27 plus or minus. And then I'm going to have negative 27 squared minus 4 times the a times the c, which is 45. So now we're actually using the quadratic formula to calculate this time. Okay, 27 plus or minus. Now what's 27 squared? I don't know. 729. And you can actually do this all on the calculator, but sometimes it gets tricky to put in, oops, the parentheses and all of that, and you don't want to get the answer wrong. Okay, so 720. Oh, this is working out nicely. Look at that. Over 8. I should have tried factoring it. Okay, so now I'm going to get 27 plus or minus the square root of 9, which I can actually do, over 8. Let's see. Then that's going to give me 27 plus or minus 3 over 8. So I get 27 minus 3 over 8 and 27 plus 3 over 8. So I'm going to have 24 over 8 here. That's 3. And then 30 over 8, which simplifies to be, let's see, 15 over 4. And then I'm going to make it a mixed number. So 4 goes into 15, 3 and 3/4. Okay, these are times, so it's going to be seconds. So the arrow's going to be at 3 seconds. It's going to be 180 feet off the ground. So the arrow goes up, and, at some point here, 1001, 1002, 1003, it's 180 feet off the ground. Then it keeps going up, but then it's going to start coming back down, and it's going to be another 3/4 of a second after that, where it's going to be back to the 180 feet. So you get two answers, 3 seconds and 3 3/4 seconds. So I'd write the answers like that.